Now here, next problem we consider transcendental equation 3x is equals to cos of x plus 1. Now this problem will solve by using Regula Falsi method, or that method we call it as a method of false position. In short, RF method. Initially, write down this equation in the f of x form. (3x minus cos of x minus 1 is equals to 0), or you can write this equation like cos of x plus 1 minus of 3x is equals to 0. No doubt we have the same output by using rearranging equations. Now first we will find out the interval where our root lies. F of 0 value 3 cos of 0 minus 1, calculate this on the calc, the value is minus of 2, substitute 1 value, cos of 1 minus 1, that value output it is 1.4597. Now we got here first value minus and second value it is positive. When we get opposite, we write down here root lies between 0, 1. So this 0, 1, first value x0, second value x1. We write down here RF formula, Regula Falsi method formula, x2 is equals to upon so this is the formula x0 f of x1 minus x1 f of x0 upon f of x1, this value same, minus f of x0. Now we denoted here x0 and x1, substitute in the formula. First value x0 f of 1 upon f of this value becomes 0, 1 into f of 0 value we have minus of 2 upon f of 1 value we required here 1.45 minus f of 0 minus of 2. Calculate this value, we have 0.5781 0.5781. Now the technique we are using here, for f of 0 we got here negative, so for 0 substitute symbol minus, and for 1 symbol it is positive. To define next interval we require symbol for this value. Put 0.5781 in the polynomial 3 into minus cos of, I will write down here, minus cos of minus of 1, and the value calculated 0.1032. so symbol that is positive we give here. Next interval this become actually this value is negative, so this value is negative, symbol minus sign, minus and plus, so these two values minus plus, opposite symbol terms we will consider for the next iteration, next approximation. Now we'll put formula as it is. This we have discussed for approximation. Now we'll continue the next approximation, that is second. Formula we are keeping as it is, only the values of x0 and x1 we are making changes in that. Next x0 value 0 point f of 1. In this formula only we are putting these values. Calculated value f of 1 1.4597, 1 into, so directly that value previously written here, minus upon 1.4597, this f of 1 value and f of this value. Calculation for the second approximation, x2 then become 0.6060. Now to find out symbol, substitute this in the polynomial. Here I will write directly that value, minus 0.6060, 3 into 0.6060 minus cos of 0.6060 minus 1. Calculate this on the radian mode on calci. So it is minus 0.0039. So that minus symbol will give here. Our next interval, minus plus, opposite symbol terms will consider for the next approximation. So second we completed. Similarly we continue for the third approximation. x0 value f of 1 minus upon respective only values I substituted in that formula. x0, f of x1 value is 1, calculated. So this calculation we have f of 1 1.4597, 1 into this value f of 1 value, that is this bracket, minus this bracket. Third approximation, x2 become 0.6070. So two decimal places, two values, two decimal places values are same. Put this in the polynomial, 3 into minus cos of minus of 1, and that calculated value minus 0.0004. So this minus symbol we put here. Our next interval become minus 1 plus. So this become our newly x0 and x1 value. Fourth approximation. Fourth approximation, x0, fourth, x0, f of 1 minus upon this value we substituted in the formula, and then we have x2, that is fourth approximation, 0.6071. Now in this case we corrected up to two decimal places, third decimal place also we have, and this difference is negligible in two consecutive approximations. So here we'll write down, hence root is See here, these are the two consecutive approximations. The difference between these two, it is 0.0001, and that difference is negligible, so that we are not going ahead to find out fifth approximation. So we completed 4 approximation. This a transcendental equation we solved by using the Regula Falsi method.